Okay, hello. I think we're all set up here. Welcome, everyone. It is December 20th, 2022. We're wrapping up the year of 2022 with the live coding stream. I guess we have a few more weeks left, so we're not really wrapping it up. We're getting towards the end of the year, and hope you're all having a great December holiday season for many of us. And we're going to do some live coding tonight. You guys with me? Anyone excited about that? Anyone out there? Doesn't look like it. Okay, so maybe more people will come later. I was getting my YouTube stuff set up. Hey, pretty cool thing over here. If you look over on Twitch, I just hit 3,000 followers on Twitch, which is kind of cool. Xcode is in the house. He or she, I think he has never been more excited. And what are we going to do tonight? Well, I have an idea, everybody. We have a brand new model that was released by OpenAI. If you look here at the GitHub repo, these things were pushed yesterday. Some of these were pushed just 3 hours. The license was updated 3 hours ago. So this is hot off the presses, y'all. And you know what OpenAI is, right? OpenAI is the company that has brought to us a lot of the crazy advancements in machine learning has come this year, in part from OpenAI. Hey, Krisha, welcome to the channel. Got someone in chat. So they have produced what? First they came out with DALL-E. Then they came out with ChatGPT and a few other things. And yes, ChatGPT is a goat for studying for tests or for just writing your papers for you. I can't believe if I was still in college having to do undergraduate writing papers, I think I would rely a lot on ChatGPT. I use ChatGPT also to help me with emails and stuff like that. Setting titles to YouTube videos. It can do that. It can do everything. But the same company that's created both of those, and then they're called OpenAI, but they're, I guess, not completely open. A lot of their stuff, they don't, they used to release it just completely open and free. And now it's kind of, you have to go through their website to use their API in order to access their models. But that's not the case. At least it looks like it's not the case with this hot off the press model, which is called Point E. I'm guessing that they're kind of going with the theme here with the E, with like DALL-E. But Point E is a system for generating 3D point clouds from complex prompts. So imagine this like DALL-E, but in 3D. Hi, join first today. Welcome Tuna to the chat. Hey, Bogoski, welcome. Haven't seen you stream in a while. Excited to see what you're up to. Yeah, I'm excited too. I'm excited to be back. We are going to look at this Point E system. So let's just read the abstract here and get a good understanding of what's going on here. I've read this before the stream, and you probably should read this whole paper, but let's just get an idea of what it's about. So while recent work on the text conditional 3D object generation has shown promising results, the state-of-the-art methods typically require multiple GPU hours to produce a single sample. So this is what I've noticed is the Point E, they're going to talk a lot about the time that it takes to run. And we're going to test this on my local machine. So what they're setting up here is they're saying that the state-of-the-art methods right now, if you want to take a text prompt and make a 3D point cloud representation of what that is, it would take hours on a single GPU. This is in stark contrast to state-of-the-art generative image models. So that's something like DALL-E, where they say they can produce a number of samples in seconds or minutes. And we've seen that by running DALL-E. If you go to the prompt and you type in your prompt, you go to the website, or you download something like Stable Diffusion, you can get your results on a single GPU fairly quickly, 30 seconds, maybe a minute or less. But for 3D point examples, it take hours. In this paper, we explore an alternative method for 3D object generation, which produces 3D models in only 1 to 2 minutes on a single GPU? We're going to have to test this out. Our method first generates single synthetic view using text-to-image diffusion model. So that's similar to DALL-E. And then produces a 3D point cloud using a second diffusion model, which conditions on the generated image. While our, okay, so it makes an image and then it makes a second diffusion model, which creates the 3D point cloud. We're going to have to test this out. We're going to have to figure out what's going on. While our method still falls short of the state of the art in terms of sample quality, so they're not claiming that this is better than the state of the art. It is 1 to 2 orders of magnitude faster to sample form. So we are going from hours to, they claim minutes. Let's go back up here to the abstract. Does not want me to zoom today. There we go. I'm going to zoom with my scroll wheel. Where were we here? Offering a practical trade-off for some use cases. We release our pre-trained point cloud diffusion models as well as evaluation code and models. So they are like straight up open sourcing this. We have the GitHub repo. We're going to be able to clone this repo, type in some prompts and see if we can get it running. I have not tested this yet. This is, like I said, just pushed out last 24 hours. So we are going to figure out. No, this is not Hugging Face. Someone's asking in the chat. This is from OpenAI. I need to go to my stream on YouTube and make sure that I ban people who say to promote their Girls 4 channel. Report. Reported. Boom, you're out of here. Oh, wait, there's like 3 of them back to back. Can someone else report these? That's why I need mods. So yeah, if you are watching this after the fact, if you're watching this video on YouTube, I apologize. This is not going to be the quick, like go through it quickly and show you the results. I probably will make a shorter video just showing this process. But in today's video, what we do on the live streams is we interact with the people out there. We try to do this coding live and we see what happens. Sometimes it fails. Sometimes we end up with a pretty cool result. You know, we've gotten to the front page of Reddit once before from what we've created on this stream. We've gotten to the top of Data is Beautiful. We've downloaded and created like 20 or 30 so data sets from scratch on this stream. So why not check out OpenAI's latest model? So it looks like, let's get an idea. Do we need to dive more into the paper? Probably should at least get a better idea of what's going on here. They're talking about the different methods of text to 3D. So it looks like there's like a single staged approach and then there's a 2-staged approach where you're basically taking a text to image model and you're optimize it for differential 3D representations. I don't know if I'm totally getting that right. Let's look at some pictures. Pictures are always easier to understand. What do we have here? You give the model give us a corgi. Okay, so then this fine-tuned glide model creates this synthetic 3D representation of our text prompt. And then they use this to create a point cloud diffusion to go to this 3D RGB. Now I did have different software that I was using to do 3D point cloud. Just as an example, I can show you. It wasn't Blender. I'm trying to remember what I did. I was trying to do a 3D point cloud of a chess piece that I had taken photos of. And it worked pretty well, but it was pretty slow. And what I had to do is, so that was a totally different thing. It was basically taking this synthetic view, or taking multiple images, and then you can feed it through these algorithms that create a 3D point cloud representation. Now, the thing with that is it requires a bunch of high quality images, and then it's doing like the matrix math to try to figure out where points exist in 3D space. I believe OpenAI's approach here is just to use a diffusion model, like a deep learning model to do it. Someone, Silent Wolf, is saying, I want to offer promotion. The price is lower than... All right, so we got someone promoting him. Why is everyone like spamming my chat today? What's going on? Let's put someone in timeout. I don't even know how to anymore. Whatever. Let's just leave that there. All right. So apparently within minutes, we should be able to create stuff like this: a corgi wearing a red Santa hat, a multicolored rainbow, a traffic cone. Some of the images that you see here, everything is in their GitHub repo. Of course, you got to have some math equations or else it's not considered a real paper. This is kind of showing the data set that they used. And then let's just go to the end where, yeah, let's see some graphs. Let's see some charts showing how it was trained. Oh, look at this. Image to point cloud, same of the prompt, a traffic cone. It looks like this traffic cone is a little bit doubled. Image to point. Excuse me. I just couldn't help but laugh at this realistic rendering of a corgi. It kind of looks like a deer or something. Qualitative results. A 3D printable gear. So this stuff's still in early stages, but it's pretty cool. And then we can see how it compares in terms of these VIT models. This is in terms of time. I don't know what this VITB32 stands for. So they're using the clip R precision to compare these. I don't know. It's hard to, with just looking at this the first time, to understand where it sits. I see this is at like 15%. And then they have different sizes of models. So let's just say that it's coming in, if Dreamfields is like the state of the art, it's coming in at like 40% and Dreamfields is about 78. So I don't know. It's kind of below average than my expectations, but it's cool nonetheless. Yeah, I think we'll see. You've used this on Hugging Face? So is this on Hugging Face? Oh, it is already on Hugging Face. A man with glasses. Maybe it can't do people's faces. Let's see if it actually works. So what Hugging Face has done is it's taken these models and made it like this user interface where we can run it in the cloud. Now, obviously, we're running their resources here, and it looks like, I don't know how they pick the denominator in this, but let's just let this run while we set up the model ourselves. All right, so we're in my repos directory in my terminal, and we are going to make this a little bigger for everyone. I'm going to go over here to point E, and let's clone this. So yeah, it does have this model card. Talk about the training data, the performance and limitations. All right, and then we can install it with pip install -e. So should we create a new Conda environment for this? Probably. Conda create name equals point e -e. Python equals, let's just stay safe with 3.9. We're going to make a brand new Conda environment. Yes, we will install this. I have had a chat GPT spaz out quite a few times, especially when it generates bigger code blocks. Does anyone know why? What do you mean bigger code blocks? Alphabet launched a playwriting model. It did? I need to look into that. The queue is so high right now. Oh, so that's a queue. I used it this morning. The queue is 20 MA. Oh, 20 max. All right, so we don't need a queue when we run it on our own machine. Conda activate. Let's close my work computer. Conda activate point E. We're in here. Now we're going to pip install -e period, which will install Dolly here. Oh, I'm not in Tmux. What am I doing? All right, so I'm going to load up Tmux here while that's installing here. It looks like the main thing it's going to have to install is Torch. Oh, I'm surprised it doesn't have a requirements.txt. Let's look at the setup.py. So these are the requirements it's installing: matplotlib, file lock, pillow, torch, humanize request, of course tqdm. So just some of the basic ones, but we're just going to create this brand new. Oh, and then it looks like OpenAI clip. It's probably the main connecting text and images. So is it built off of the back of clip? Yeah, it does look like it's taking clip and then it's doing the point clouds from that, I think. We have someone in YouTube chat, Venus, asking if I look at YouTube chat. Kind of come over to Twitch. It's a much better place for me to check out what you're saying. I have an idea about a store writing app for parents. Imposter Engineer, I'd love to hear it. My kids have loved reading some stuff that's been created by ChatGPT. So let's look up this. Where's this AI assistant will impact all field alphabet? I thought you said that there was a new playwriting model by them. All right, so this is done installing. What we're going to do is go into my Tmux section here, close out of this one. We're going to exit out of here, and then we're going to go Conda activate point -e. And then we need to install Conda activate Kaggle 2. We're going to load up Jupyter Lab here. Now we need to add Conda environment to Jupyter. I always forget how to do this. This is something I definitely need to memorize. I always go to this site. So I think there's two ways to do it. Pip install ipykernel into this other repo we have, or this other environment we have. ipykernel. then IPython kernel install user, and let's name this point E. There we go. Now if I go into my Jupyter session, which is here, let's go ahead and clear the workspace. Bring this down in size a little bit. And then let's go into this examples folder. They have some example data. This is their example corgi. Okay. So image to point cloud is second. Point cloud to mesh. Text to point cloud. Let's make a duplicate of this with a test in it. DeepMind, GitHub. Oh, it's from DeepMind. Dramatron. We're going to definitely look at that later. All right, so what do they say in the docs to this? We're going to open up the README here. We've installed it. Get started with examples. See the following notebooks. Image to point cloud. Sample a point cloud conditioned on some example synthetic view images. So that's what we're doing here. Okay, so no module point E is installed because we need to go to our point E kernel. And we're going to call this image to point cloud test. All right, what's going on here? Let's see in my terminal MVTop. It looks like my second GPU is being used by OBS. So if I use this first GPU, we should be good to go. So instead of this, I want to make my torch device is torch device 0. Invalid device string. So I think it's just like this. Device. Yeah, that's my CUDA index 0, which should be my first GPU. Hey, Rob, I love your work. Keep it up. Thank you, Xiaomi. Xiaomi. Hope I'm saying that right. All right, creating base model. So I'm assuming this is going to download a model from this model configs. What's model configs? So it looks like we have this, all these different models. There's probably different sizes ones also. Model configs comes from models.configs. Okay. So we're using the base 40M, and it's saying to use 300M for better results. Let's try that second. All right. So for some reason, I thought 40M would be 40 megabytes in size. But this is much larger. And yes, I would buy an app to build that does this, but short bedtime story format. Is it okay live streaming on YouTube and Twitch together as affiliate? I don't know. Anyone know why doesn't use VS Code? I'm new here, guys. Take it easy. Oh, I use VS Code sometimes. You can watch my YouTube video about my setup. Like, I was coding for work all day and using VS Code. But I think for what we do here on live streams, notebooks can be really helpful because I can kind of jump around, execute a cell of code, and then you guys like follow what I'm doing. Maybe a little bit more. So that's the reasoning behind not using VS Code. But I do have it here. Like, I can load it up if you just want to see it here. This is some of the code we were working on the other day. Now, I have been working with Copilot the last few weeks. Just the past week, actually. And I've been really enjoying it. All right, so we've downloaded... Where's this download to? What's the directory? Is it in this models directory? No. I wonder where it downloads it to. I guess that's not, it's not in temp. No. All right. This is now we're going to download the upsample model. It looks like for model configs, there's only one upsample model. What does upsampling model do? I don't know. But it's not like we have a few to choose from that. We just have this one upsample model to download. Okay, so we'll figure out where the dictionary actually is by using this load checkpoint. Wait, what does load checkpoint do? Load checkpoint is from... Yeah, you know what? It probably would be a good idea to load this directory in VS Code. So if we do code here, now we'll actually load up this point E model. Models dot download. So these are where all the models are downloaded from on the internet. Fetch file cached. Where's my local dir? If cache dir is specified, it will be used to download the files. Otherwise, default cache dir is used. So it's the current working directory. So that means that in our examples, point E examples directory, this is where we're working. Yeah, now there's this directory called point E model cache. And we can see, yeah, this is the VIT model that's 890 megs, and this is the base 40M. So the base 40M is only 155. Hello, fellow DS here. Fave pizza toppings are olives and onions. Nice, Leeson. Welcome. Welcome. So what are we going to do here with this brand new model? We have at our disposal. We are going to try something out. Okay, so yeah. If you're not familiar with torch models, basically this loading checkpoint weights, this actually gives us like our model weights. Right? I think we could do a shape. No. So this is like an ordered dictionary. And these are all the different layers within the model. So you could do a shape on this. This is like the first layer. This is like all deep learning models are a bunch of matrix multiplication. But the beauty and the awesomeness is hidden within the weights that have been trained in these deep learning models. So this first layer is 2048 by 550, 512 matrix, or tensor you could think of. Sometimes they're 3D, right? So I think because this is an ordered dictionary, we could do like, no, we can't. So we could do keys and see these are like all the different layers that it's using. And then there's also the configuration. So, yeah, basically we don't need those model weights anymore. Let's download the base checkpoint. So what we do with PyTorch is we load this model. So this base model is basically this shape of like an MLP with this layer, these different layers. And this is telling you like how to connect the dots of the weights of the model. And then when we load this checkpoint, we're loading the save checkpoint that the model has been trained at. That's like our model weights that we saw here. And when we do, when we take this base model and we load the state dictionary like we did before, you could see that it's checking to make sure that the shapes of these PyTorch tensors are the same shape as what the model expects. And it says, and it actually names them. So that it checks the names. It says they're all matched successfully. So sometimes you'll find, like, if you had like a ResNet, a smaller ResNet, and then you try to load in weights for a bigger one, it's not going to work. Everything's got to match up. Sky is the limit. Last time I was on the stream, you still spun the wheel for new followers. Bogodsky, that was a long time ago. So I've switched to spinning the wheel every time I get a sub. And if you'd like to subscribe on Twitch, feel free. Please do it for free using Jeff Bezos's money. It's free with Amazon Prime, is what I'm trying to say. All right. So now we need the point cloud sampler. Where did this come from? Let's actually look at this. Sorry. That's from diffusion.sampler. This is the class that we're loading. It's a wrapper around the model or stack of models that produces conditional or unconditional sample tensors. By default, this will load models and configs from files. If you want to modify the sampler arguments of an existing sampler, call with options or with args. So we give this a device, the models, the diffusions, the number of points. And luckily for us, they've already done all this. And then the channels, I guess, are RGB. This is for our output image color, red, green, and blue. Guidance scale. I don't know what that does. So now we have our sampler. If we do a type on this, it's a point E diffusion sampler, point cloud sampler. All right, so then we're going to load this image to condition on. What is this image of? It's of a box and another box. Okay, so what we're doing in this part is taking an image and we're trying to convert it to a point cloud. So this is just one of the stages in the... So I guess this is like the big thing that it's actually doing, which is creating this point cloud from this. All right, so we don't know how many I don't know how many iterations this is going to take, but I can go look now that this is running and see that it is running on my first GPU. I'm glad everything fit into memory. With a larger model, we might not be so lucky. We're running the smaller model, and they said that that should run in a few minutes. And then what we're going to do is take these samplers and pull out the point cloud, it looks like. And then call this plot point cloud method. Plot point cloud method. I can't speak. So that's in the utils. Plotting. This is renders a point cloud as a plot, the given image path. So it's just using matplotlib to render it. So I believe what we're doing right now. How do I create an app with OpenAI? With this, you could just, it's free. You could just throw this into your app. Yeah, you got me more excited about data scientists. I'm Cornell's data scientist program at work right now. That's nice. Been for a while. Bogodsky, good for you. Yeah, so we're now it's done. So it took 1 minute and 25 seconds, and we're gonna create this point cloud. Okay. All right. So what did this do that's so amazing? It took just this image, and made the point cloud from it. Should we try something else? Like that's pretty darn good for estimating this in a point cloud. And remember, this point cloud that we have, this PC, there's got to be a way to render it actually in 3D. Like using Plotly or something. Plotly point cloud. Point cloud in JavaScript. We need a 3D point cloud. 3D scatter plots. So I've seen this before. We can try. Feeling this is going to break. Oh, because it has red, green, and blue for each. It's not subscriptable. What's the shape of this? Oh, that's right. So this is just the location of all the points in 3D space. So let's try to use Plotly Express. I'm going to have to go into conda activate point E, pip install Plotly Express. I think this should work. Bogosi's responding to himself. Plotly 3D is easy and great. Yeah, I agree. Chris says. So we're going to try to just do this. Colors are going to be question mark though. Because it's not that we want to plot points with a specific color. It's a RGB color. So they're giving each one in a different... They're giving each one in a different channel. It needs a data frame. So we're going to make this a data frame from our coordinates, right? And let's put the columns as, let's just call it X, Y, and Z. And then we're going to do this equals chords. And it doesn't like it. MIME type renderment requires NB format. Okay, so we need a pip install NB format. All right. MIME type render equals, but we have it. I might have to reload this. I might have to reload this kernel. Before I do that should we try the bigger model? I think we should go ahead and try the bigger model. I'm going to restart this kernel. Now that we have everything installed, iProgress not found. Pip install ipy widgets. Here we go. Is there a difference to using pip install and then conda install in a conda environment? I have found that, so conda can install like compiled binary files. Pip is mainly just for Python packages. I used to use, so you can use conda just straight up. But I found that pip just works better for Python package management. So I use pip. Many of these things I could have just conda installed, but for instance, like the point E probably isn't on conda forge. So it's not like someone pre-built it already. Conda is installing from a preset and pip is installing from PyPy. Yeah, that might be a better way of explaining it. How did I created this larger model, but I thought it would have had to download it. Base 1B. Let's remind ourselves of what these models are. Base 1B. I'm assuming that's the biggest one. Once this is done running, I'm going to reload this without using TQDM Notebook because I think it's not rendering our progress bar, which is infuriating because I need to know the progress. Yeah, that's just the parameter size. But I think it actually, so XUTW, so I believe that now we're loading a checkpoint that's much larger. So if we go here into this cache directory, we can see like the 300M model should be downloading. This is the temp file that it's downloading, and it's already at 1.1 gigs. And that's the medium-sized model. Yeah, and it looks like it's done loading now, so this should be done. Yeah. And let's reload this. So let's clean this up a little bit. Because I think all this could be just done in one cell. Nothing has to be downloaded anymore, I don't think. For this version at least. Base name is here. Need to run that first. So below here is the 40M model results. Was that the default, the 40M? Yeah, 40M. Now we're doing the 300M results. So in order to do that, we need to take this model, run it here. Oh, we haven't created our sampler yet. We could show this image again. And now we can run this. This should take a few minutes. Let's see how it's doing on the GPU. It's still only using 6.4 gigs. So the model itself is a little bit larger, but even if we have a lot of space here. So one thing that happens when I run these, hey Shanty, welcome to the chat. Yo to you. But one thing that does happen here is keep in mind that the GPU needs to have the complete model in it. So the model can be like gigs, multiple gigs of size, and then what other data you're throwing on it. So if you're training, like whatever batch size you're throwing on there, or if you're running inference on this, it's like the 3D output. So on like stable diffusion, I was finding that we were like really hitting the limit of what my GPU can handle, because these are pretty old, small, not a lot of memory in them. I gave away a GPU that had a lot more memory than my own machine, but I have two of them, which is nice. So we're going to see what this looks like. While that's running, let's see what will come next. Okay, so this next notebook that we'll look at is actually taking text and creating a point cloud. So I think that's the two-stage of point. Use our small, worst quality, pure text to 3D model to produce 3D point clouds directly from text description. This model capabilities are limited, but it does understand some simple categories and colors. We'll try it out. All right, so it's still going on. Time for an upgrade? Yeah. Okay, so here's the point cloud result. Trying to recreate this using the 300M model. I don't know, anecdotally, does it look better? It's a pretty simple object to start with, so I'd say inconclusive. But what we should do is try to use a different example image. Does anyone have a good image I could use? Let's do a 3D rendering of a cartoon dog. Put this on my desktop. I don't know if it's going to be the right size. We'll see. So go here. Let's move it from downloads. What was it called? Cartoon dog. Here. And now let's try to load that in. There we go. There's our cartoon dog. Let's delete all this stuff. We're not going to mess with Plotly Express yet. So we can try to send this image of a 3D dog. Maybe the background being not white will be an issue. But we'll see. Added random shadows. Oh, you're saying this added random shadows? I can't tell if that's like a gap Or if it is shadows. Yeah, because this one does have a shadow back here. Very dark shadow. So maybe that's what it's trying to create. What do you guys think? Is this interesting? Curious to see about this dog. Yeah, we shall see. And I want to see what this 1B model looks like. But I also want to see what the text, if we can get some of the text to 3D points working well, that will be cool. What I'm realizing here, though, is every time we run this, we do have like a minute to 2 minutes of time to kill. So it's not the best like action-packed thing for a stream. So feel free to ask any questions you might have. I mean, these are some of the examples they're showing. Look, this is the 3D rendering of that cube. I mean, these headphones look pretty good. Isn't there another one that could do 3D from images? You mean in addition to this, or a different one this? Imposter Engineer. I think there are a few like a stable diffusion ones. Chris is asking YouTube why the name change from Medallion Data Science to my name, Rob Mulla. I felt like it was just time for a change. I'd kind of been avoiding using my real name because I was a little embarrassed of streaming stuff online, but I got over it. Okay. What do we have here? It's a dog. It is a dog. It's not that bad. I mean, you say poop, but I say not that bad. Let's plot it a little bit bigger. Point cloud. Color. Grid size 1. There it is in 3D. I don't know. It seems pretty crazy that it could do it that quickly. I mean, I think we're just looking at the early phases of what's potentially possible. Let's go to the text to point cloud though. That's their second example that they suggest using. So I'm going to duplicate this one. Call this test. All right, let's see what we're doing here. It looks like a lot of same things. Configs, diffusion from config, point cloud sampler. Text to point cloud. I wish we could get the Plotly thing working. But yeah, I have to use the right conda environment. Make sure I use the right conda device, which is going to be zero. All right, so I think it's going to have to download this base model, which is the base 40M text vec. All right, so before we were using just the 40M base. I see. Okay. So it looks like maybe from the image vect and the text vect, that's why they're saying here in the documentation. Our small, worst quality, pure text to 3D model to produce 3D point clouds directly from text descriptions. It's limited. So it's not using the larger model, I don't think, but it has downloaded. Now we have create the sampler. All right, it says a red motorcycle is what we're going to try to create. So let's just go with that. A red motorcycle. Take out this TQDM auto. No, it failed. Did it run out of memory? Did it run out of GPU memory? Because we're going to be stuck then. Oh, you know why it ran out of memory? So I have this, I hope this is it. I have this other kernel still running. So it was trying to, like, they're both fighting for memory use on this GPU. Which is fine, because now I can restart. Don't know why my scroll bar on the right there is kind of... Looks like a cape. What? Wait, I missed when you said that, VX. Which looks like a cape? This? I think it does. Well, like you have to... Yeah, you have to think that this background is definitely screwing with this 3D image, make it look like a cloud. But for what it did pick up of the 3D dog, I mean, it's pretty dang good that it could figure out this shape of this head. Like, just think about this for a second. This is just an image. This is just a flat image we just downloaded from the internet. And it knows enough to know that this is the shape of the head based off of it. I think that's pretty impressive. Especially coming from, I was trying to take these chess pieces and figure out the 3D point cloud of those. And I mentioned this earlier on the stream, but I had to just take pictures of all around the image or all around the object with good lighting. And then it still had to run for like 15 minutes just to make a point cloud that I think looked similar to this in quality. All right, so it's done running our bicycle, our red motorcycle, sorry. Let's see what this looks like. Dang! That's not too bad. I really want to get the Plotly version of this now. That's pretty good, right? Anyone else impressed? Dog reminds you of Mr. Peabody? Okay, so this is how we do the 3D rendering. Let's try to do import pandas as PD. PD data frame with the chords. Oh, point cloud chords. Just because it'll be cooler to be able to spin it around, right? So we're going to use Plotly Express. But I don't think we'll have the colors to start out with. Oh yeah, and I need these columns. X, Y, and Z. Now I know my ABCs. And color's going to be nothing for now. Will it work? Will it blend? Hey! Hey! It works. So think about this. All right, let's try to get the colors working. So point cloud has colors, then it also has G. No. Oh, channels. R. So these are all the red channels. So basically chords, good work, thank you. So this is gonna be R, 4 channel in RGB. We're just extracting these out and putting them into our data frame. All right, so now we have a RGB channel. Pandas RGB to hex. Let's see what the answer is on good old Stack Overflow. None of these have any upvotes, which is a little bit scary. Really? This one has 5. Okay. Apply lambda RGB to hex. How do we get RGB to hex? Oh, did they already give us that? That's this. So then we can do chords df apply lambda x RGB to hex x axis equals 1. I think that's what it'll do. And this needs to be oh, we need a star here. Look good, guys? Does this look okay? Six were given? Oh, okay, so we need this. R, G, and B. We need a subset to these columns. An integer is required. Okay, so does that mean that we need to take this? We need to multiply it by 255. And then we need to do as type int. So the reason is why these channels data in the point cloud are in looks like the format where they are the min value is going to be 0 and the max is 1, like scaled from 0 to 1. And typically in images you'll have it be between 0 and 255s as a like a uint. Watch it not work still. So did I run this? Chords. Info on this. These are integers now. Yes, now it works. Color hex is what we're going to call this. We're going to throw it all down here. Aren't you guys excited about this? We're going to make it colorful, hopefully. Color is color hex. Color what the hex? Is it going to break? Shoot. Did I break my computer? I think I broke my computer. Oh, shoot. Am I still streaming? Is this stream still on? I didn't expect this to like break it. It's super cool to someone. Nice. Thanks, Bogodsky. Let's... Okay, as long as the stream's still up. I don't know why this would have... Maybe it doesn't like hex colors. Maybe it actually wants a RGB. Maybe it's just having a hard time rendering it, but it didn't have a hard time rendering it without colors, did it? Yeah, I'm getting scared here. So I'm just gonna kill this kernel. And I like that soundtrack we were listening to, so let's just reload that from the beginning. Okay, so we just started over from scratch. And granted, we haven't even tried like the large one. The large point cloud. My soundtrack is Synthwave Retro Mix on YouTube. It's supposed to be copyright free. That's my big thing, because otherwise my videos will get taken down. There's a lot of music I wish I could listen to on stream, but then it would get taken down, and that's no fun. All right, so this took like a minute and a half to render last time. I'm trying to think. Oh, you know what I'm realizing? Here's what happened. This scatter 3D, it expects this color column to be like an ordinal, like a categorical value. And it's just going to make them different colors. You should find a way to split the audio tracks and exclude music. Yeah, that would be cool. So is there a way in Scatterplot 3D to just make it maybe the hue? Color discrete sequence. String should be... I was assuming that I would just be able to plot it with the hex value as the color. String should define a valid CSS color. This is the list used to build a continuous color scale with a column denoted by color. Contains numeric data. Plotly express 3D scatter with hex colors. See, this is still doing it like the continent is the color column, and then this is just the sequence of colors that you're providing it manually. But this doesn't actually let you make each color different. So they're saying the marker size color is spent. I don't think this is what we're trying to do. Oop. Hover template. So this is having to actually do JavaScript, I think. Ooh, this is kind of doing it. Light orange. Color equals custom color. Custom JSON data font wrote a color. According to the maintainer of Plotly, Nicholas, the official documentation that unfortunately, if you want to use a specific color for every item that is going to be plotted in the final image, you just need to use the color discrete map equals identity argument when calling your plot. Oh my goodness. That's all it needed. Why do I have two of these open? Okay, so we want to do this. Now we have our image again. Color discrete map. Let's just do like a head on this. PC is not defined. Why? Oh, because we haven't run this cell yet. Now we have our point cloud of our motorcycle. So all that we gave this was a red motorcycle as a prompt. Oh no, you have more than 3 colors. You have a lot more than 3 colors. Does it have good details on human faces? I don't think so. Sorry if I've been ignoring you all in chat, but VYXP looks like you've been trying to help here. No, it froze again. And I even just did the first 50 to test it. It ran, kind of. Okay. It didn't completely freeze on us. There we go. So this is working. This is working, right? But it kind of freezes up. So let's just sample. I saw a shape earlier. Let it run. Let's do sample 100. It's just going to randomly sample 100 values because the chords data frame is 4,000. And it does freeze right when I hit run. Because I guess it's a lot of samples for it to make. But we did figure it out, how to make the image work, how to make the color work. Let's look at here. Identity. Alternatively, the use of color or valid colors to string identity may be passed to use them directly. I totally missed that earlier. That was the answer to our question. Okay, so here it worked with 100. Should I go ahead and try to do 1,000? Let's also make the size. What's the default size on this? Size. Let's do a size of 5 and just do like 3 of these. Oh. Marker size, maybe. Let's not deal with size. All right, let's just do sample 1,000. Need a 3D size. Yeah, I think I need a size for every row, every value, one of these 1,000, which I would just change then. A little weird, but we can get it working. All right, I need people in chat to give me an example that we could prompt that we could give this. So just from the paper, some examples that they show. A corgi. A corgi in front of a white background. A 3D rendering of an avocado chair imitating an avocado, full view, white background. Should we try that text prompt? I believe this Plotly Express stuff might be interior of a kitchen. Bro, this is ChatGPT 3. Who's saying that? This is not ChatGPT. This is... I mean, it kind of is. It kind of is Dolly. It's like a not as good Dolly, but it does it in 3D. I'm going to shut down this kernel because the 3D plotting, it's cool and all, but it's just not worth the headache right now. So let's go ahead and reload this. Did I already make something? Yeah, so we ran the default one, which was them. The prompt is a motorcycle, a red motorcycle. And I can show you what it looked like here in a second. Let's get this to shut down. Every time I do a stream, I look at myself and realize I need a haircut. Today is one of those days. All right, so this is what we did before. We gave it the prompt, a red motorcycle, and it came up with this result. Then we tried to plot in 3D, which would work, but it's just going to take too long, and it's making my computer freeze. So what's another? A banana phone. Okay, let's try banana phone. Someone in YouTube gave that suggestion. That's a good one. White background. 3D. See, these things like more specific. 3D rendering. Full view. 3D rendering. Full view. Yellow. Banana phone. Did I spell that right? So also see while that's running if their plot point cloud what parameters this takes. Yeah, it doesn't really take that much. Banana phone. Here we go, folks. Do you think it's going to look anything like a 3D banana phone? On a scale of 1 to 10, how excited are we going to be for this banana phone? Let's check it out. Banana phone. What? What is this? It's yellow. It's yellow. I'll give it that. It's yellow. Banana blob. Banana. Well, here's the thing. Phones nowadays are just kind of like a square. It's not like an old school telephone. Let's give it this one. A simple view of a 3D rendering of a corgi in front of a white background. This is the text prompt that they said they gave it. $4D banana. I like that. Someone said 4D banana. It's more like a 1D banana. Like divided it. It took out one dimension. See, I don't know if these images on the right that they're showing, examples, point clouds left and the corresponding extract meshes right. We find that our methods often produce smooth meshes and remove outliers, but sometimes miss thin, sparse objects, bottom row. Okay, so, all right, we have the corgi prompt. Let's see if it's what we expect. I don't see how this corgi could be. What? What? What is this corgi? That's not a corgi. I mean, I know they're trying, but come on. Now I'm starting to think, hey, we got a subscriber. Yes. Who subscribed? AKRWP, thank you for subscribing. What do we do when we get a subscriber on this channel? We spin the wheel. The wheel of fortune, the wheel of fame, the wheel of me probably screaming something out loud. And it's landed on drink water. Okay. For you. I'm actually quite thirsty, so that worked out. Thank you for subscribing. By the way, if you're not watching on Twitch right now, make sure you go there. Check us out on Twitch. And yeah, use the subscribe button. Hook it up to your Amazon Prime, and you can subscribe for free. So here, what we're going to do is make sure I'm using the same model. I don't know if the size of the model matters. What's the base name that I'm using? See, that's the thing is the models, there's only a 40M. Maybe they didn't provide the other models. There's only a 40M text to vec. So we're going to still try a few things. What I want to do now is go on to this final one, which is image to point cloud. We're going to duplicate this. Oh, sorry. We already did image to point cloud. We are going to do point cloud to mesh. Let's test this. Let's make sure we shut down all of our running sessions. And let's see what this is. And of course, I need to change my kernel. Are we hacksering stuff? Yeah, we're hacking. Oh, shoot. Did it load the right device? I think it did. We also want this to just be TQDM. Device equals torch device 0. Hey, we got a gift. Thank you. We got some gifts. What is this? AKRWP. Thank you so much for gifting a sub. Let's go ahead and spin this. So it looks like what this next thing is going to do is it's going to take a point cloud and it's going to try to make it into mesh. Another, oh, science mic. There you go. All right, so now we have their corgi that they've provided us, which is like this point cloud version. And we're going to use their model, which will take this and increase the resolution. Okay, so we're going to start 32. And then it wrote it to a mesh.ply. How do we open a PLY? CTM viewer? Could this be it? I think this might do it. Now we have CTM viewer here. We're going to open up this file, which we have just created. Can I just do it here? Help here. Unable to open the file. Okay, so it needs a file name. So the file name is here in our .e examples that we're working in. Mesh.ply. There we go. Here's our corgi. Look at this corgi. So my question is, what? Okay, so I think that we can put this all together, basically. We can give it a prompt. We can have it, or we can have it come from an image instead of a prompt. I think we should do it from an image first. Can someone find me a good image on a white background of something in 3D? Maybe something funny? I can try testing over here. What if I try this? The white background is the hard part. Oh, shoot. Did I freeze? Am I still here? It like froze for a second. So why you don't stream from the same box that you are? Steady Search said yes. Yep. Oh, wait. Are we doing text to 3D images, point clouds? Yes. Yeah. So what we're doing here, just to catch everyone up, this paper was released just today or yesterday with .e from OpenAI. It's a system for generating 3D point clouds from complex prompts. Now, it looks like the prompts is just an option. You could also just take a 3D image. Okay, so here's some examples they give we can try. Let's try doing some of these from the start to end. So we might have to redo the kernel. We'll call this end-to-end test. We'll restart everything that we're running. Step 1, prompt to point cloud. Or we could do an image. So one thing I was thinking is, let's do the prompt. So we're gonna need to do this. Make sure we choose the right environment. And then what are we going to do? We're going to take this text to point cloud and we're going to make this into a function called get point cloud, where we give it the prompt. And it's going to return to us. It's just going to do everything. Create our sampler. We could also give it the base name. And then it's going to return the point cloud like this. Output to point clouds. Return point cloud. All right, so this should take our prompt and make it into a point cloud. So we're going to try one of the examples they have in their paper, which is a pair of 3D glasses. Left lens is red, right is blue. And we're going to let it just create the model and go through it. Let's go, people. Someone is saying my stream is very EU unfriendly. I was binging all your videos. Finally get a chance to see me live. Thanks for watching live. I appreciate it. Taking the time to hang out with us on this fine evening. So we're getting our point cloud, and then we can plot this. And we should also probably save the point cloud first. Save the... let's plot first and then save. What in the world? This is not good. A pair of 3D glasses, left lens is red, right is blue. Am I missing something here? It worked well for the motorcycle. It's bizarro. These do not look like glasses. So it's probably not even worth going in saving this off because it's not good. This motorcycle was pretty good. Let's give it a different prompt. A blue bicycle. A blue. I can't spell, man. Bicycle. Let's see if it likes the bicycles. What, the question mark? Yeah, I don't know what's going on here. It's probably that I'm just not doing it correctly. So let's make sure selected point count generated by point using given text prompts. For each prompt, we selected 1 point cloud out of 8 samples. But you're not telling me that that one like blue circle eventually, if I ran it 8 times, one of them would look like this. I think maybe it's because this is my guess, but my guess is that Here they give us the base 40M for text to vect. That's what we're using. Maybe they use the base 1B text to vect, and that's what they're showing in their paper. And we just don't have access to the whole thing. So maybe what we should try next is actually image to point cloud, and then point cloud. Yeah, so blue bicycle looks pretty good. Blue bicycle looks better. I don't know why. It likes the bicycles. But we are using the smallest model they have. And let's go ahead and do the next. Save the point cloud. Blue, we're going to save this NumPy array. Import NumPy. Okay, so it needs a file name first, and I don't know if it's going to actually be able to save this. Okay. So it did save. And let's see when we loaded this PC Core Z. Oh, so point cloud has a load. Okay, so there's this load method within theirs. From point util point cloud. Point cloud dot save. Okay, so we should just be able to take this and save like this. Blue bike NumPy. They actually saved as NPZ. I like this music. All right, so we saved it off like this. Load the point cloud and convert to mesh. So now we're going to convert this to mesh. Let's go ahead and close out our other mesh of the Corgi and try to do this mesh stuff in here. Point cloud to mesh. And we'll give it the point cloud. And this will produce the mesh. We'll write it. And then let's return the mesh. And this will be blue bike once we get it back out. Our mesh is going to be this point cloud to mesh, which is our point cloud that we already created. Marching cubes mesh is not defined. Did we not just load all this in? Oh, I didn't run that cell. Let's also do this. Okay, 2 QDM's awesome. All right, let's try to see CMT viewer of our blue bike. What the? This is not good. So it said it didn't do a good job when things were thinned. And it clearly did not do well here. And again, I could be running this incorrectly. I could be running it incorrectly, but our point cloud mesh, it did look pretty good up here. And the name of the model configs cross attention point cloud SDF model. I mean, in their examples in the paper, they do show this purple vase one not doing well when it converts it to mesh because it's so thin. So let's try to do an image to, let's do this exact same stuff, but from an image. Maybe try lemon bar. You Canvas, you're gross. You're gross, man. All right. Let's try another. I don't want to try prompts because they're just not going to work. Yeah, we tried a few and they just didn't work. So let's duplicate this. Let's rename it as end-to-end, starting with an image though. Image to point cloud. So here we are going to take our example image to point cloud. And let's use the Big Daddy model. All right, so our we're going to take all this out and we're going to create a new function called, let's just call it image to point cloud. We'll give it our image and our base name. Our base name is going to be default to this 300M. Then we'll make our 3D point cloud sampler. And we will load in our example image. And this is gonna, we need to return the results of this sampler, which will be like this. Return point cloud. And let's try this example image that they give us. We need to load in. This is our image. Then we are going to do image to point cloud like this. Device is not found. Okay, so we need to do devices GPU 0. Probably should make this a parameter, but that's cool. All right, any other questions? People in the chat, what's up? Talk to me, people. Are you impressed by OpenAI's latest release? Let's be honest, we're spoiled a little bit with all the stuff OpenAI has been giving us, and they're noting that this is kind of like early versions. If we looked at the first version of DALL-E, I mean, it kind of reminds me of this. Like, in 2 years, we're going to see this working crazy good because they're going to have perfected it. But this is like point E 1.0. I still don't understand why my point clouds do not look as good as this. The Para 3D glasses did not look nearly as good. Only thing I can think of is if they're creating these images. They don't explicitly say, but if they're doing it using this base 1B model. Well, still a lot of work to do, and I mean a lot. Work to do what? To make this? Yeah, this is still... It took them a lot of work to create this, if that's what you mean. Oh no, I lost my music. All right, so it's still running our point cloud. The reason why it's taking longer is because this is the bigger model. In 2 months, I guess the demo for movie production will be ready and can create it in 30 seconds. Yeah. Maybe they're just trying to set our expectations low for when they have the big reveal. Now, do I have image to point cloud open? I do. So this GPU's probably being clogged up by these. Need to shut this down, shut this down. Okay, so now it's done. This is our point cloud of that 3D image. And then I'm going to save this as blue square, I guess. And then we're going to we created a mesh out of this. So, oh, that's the other thing. You know what could have been wrong with the other one? It said to increase this grid size. So, yeah, that's the one thing that I didn't change. Waiting for hardware progress seems like computing fell behind. Yeah, I think that, so the big thing with all these crazy models is most people just want to access it. Speaking about hardware issues, maxing out this. But yeah, people just want to be able to run this on like a website. Oops. And in order to do that, they need to pay for a lot of instances. Okay, this is a little scary looking. It looks like it's bleeding. I mean, but that's not bad. I think I want to try the bike again with the higher rate. Yeah, so let's try the bike again. Let's try this bike again. So if we do point cloud load, good thing we saved it off, right? Blue bike. And let's make this grid size a parameter that will default to 128. All right, so then we'll make the point cloud bike. We'll write this out. At 128 grid size. Do you have any opinions on 5nm AMD processors? I don't know. I'm not the most up to date on that. My machine's kind of old. Although me and my son are going to be building a computer here soon, so maybe I'll be more up to date on what the good stuff to use is. Okay, so remember the shadow? Oh, it's scary when you're inside this. But look at these edges. That's pretty impressive. All right, blue bike is still womp womp. Even at that high resolution. Am I running the right one? Oh yeah. So blue underscore bike. There we go. Excuse me. Okay, so this was just from a text prompt. We just wrote blue bike and it was able to create this. That's pretty cool. I wonder if I changed, can we increase this even more? Can we now make the grid size 256? Hey, we got someone named Pie Trader Detective chatting in YouTube. What's up? You should buy your son a 4090, a computer with a 4090? Yeah. Well, it's going to be on his budget. So we'll see what he can afford. Although that is his birthday gift, is something towards it. I mean, not birthday and Christmas gift. All right, here we go. Where is our blue bike? We are now rerunning at 256, and then we want to get a 3D image. Let's get a good 3D image. You know what? We can actually just use DALL-E 2 maybe to create a 3D image of something and then use that. Banana phone. I want to go back to the banana phone. 3D rendering. And let's see how this looks. Banana Man 3D rendering, white background. Full view. Some kids have tennis lessons that cost like $50K a year. Whoa. Banana Man. Well, let's save that there. Let's move this from where did I save this? Banana Man, white background. Oops. Save. All right, so now let's move downloads. DALL-E Banana Man to here. Let's rename this Banana Man.png. And let's see if we can do this end to end with this image, but with the Banana Man. If you guys can find a better example, I'll take it, but for now, let's just try this. And maybe that'll be a good stopping point. All right, so we already did this. Image to point cloud. We're using 300M. Maybe we can use that 1B at the end. See if it works. Now we're going to use Banana Man, which is this image of a banana man. And we're going to try to create the point cloud for this. We need to have like a name, which is Banana Man. And then we need to, when we save stuff off, save it using this. Use our name so I don't accidentally overwrite some other stuff. Banana Man. And we can delete this. All right, so it's creating our Banana Man. Look at the blue bike. Did it get bite? Did it get better? Yeah, did we look at the latest blue bike? Blue bike. Thought we looked at the latest one. Yeah, it looked like this. Maybe we didn't look at the one with the higher resolution, but it's just kind of thin. But it is a blue bike. I mean, bikes can be thin. It does have like the protruding of the bicycle pedals. It is blue. I think this is the latest one. Someone said I've been using ChatGPT to help me some coding issues. It's awesome, and I think it will supercharge the process for everyone learning to code. I agree. I think it's a real game changer. It really is. Like, I did not think it would be possible to have something like that as helpful as it is, all things considered. Like, we had been having chatbots like that are not very helpful for a while now, and it just seemed like we wouldn't get over the hump. But these diffusion models are crazy. You can use Point E on Colab. Yeah, I'm assuming all this stuff you can run on Colab. I like testing it out locally. Hey, there's our 3D man. He's like dancing. He's like ice skating. Okay, so our Banana Man, we're going to save this point cloud. And then we're going to do the point cloud to mesh. And while that's loading, let's think of a better prompt. Maybe 3D rendering of a puppy with a yellow puppy with a red collar, white background, animated. All right, so we have our Banana Man here. Nope. Need the full name. Here's our Banana Man. Oh my goodness. This is... What do we think about this, guys? What do we think about this? This needs to go in a museum. That needs to go in a museum. What? Okay, just so we know, remember, that's it. I mean, it's kind of hard to know what stance he is just from a 2D image, but hey, there we go. Look at that. Can we try to get the angle that it was looking at? It's not horrible. I'm not gonna lie, it's not horrible. We got to 3D print it now. Yeah, will it snap right here? I think some of this stuff would just straight up snap if you 3D printed it. But I would do it. We got a big gap here in his armpit. Man, what deodorant is Banana Man using? All right, so 3D rendering of our dog. Okay, maybe this will be easier for it. I don't know, like the shadowing. Only have 6 credits left. Oh no. Try specifying a focal. Is that possible? These are kind of scary dogs, but let's go ahead and download this one. Move this file. Puppy.png. And let's try running this end to end again with a puppy. We got to get our puppy in here. Got to restart this. I don't know. In Dolly 2, but sure in Stable Diffusion. Oh, so how do you do it? Like, what do you say? Someone's saying to specify the focal. Maybe you can fix the perspective. Give me an example of a prompt I should use. Or send me an image. We could do that. I got to double check that image off screen, though. I don't want someone to photobomb me. All right, let's restart this. We're going to try this puppy. Now, here's a question. Should we go with the huge model? We haven't tried it yet. We haven't even downloaded the model weights yet for the base 1B, I believe it's called. Yeah, base 1B. So we're going to do puppy. There's our puppy. And then we're going to do base name base 1B. It may not fit into my GPU's memory. Uh, 35 millimeter full frame. Let's try it. And actually, I want to restart this. Did the 1B... Let's remove the base 1B stuff so I can start it over again with this. Yeah, and then let's try this image like you were saying. No shadowing. And you said 35 millimeter full frame. So a yellow puppy. Oh, okay, this is good. I kind of want it to be full. Yeah, this is not full frame. I don't know why. What do we think? Are these better? It's kind of scary. Maybe take away animated. Okay. 6 millimeter. Oh, why can't I copy her? Copy this. I'm running out of credits here, so this one better be good enough. Oh, he looks so scared. These look kind of scary. Full frame. White background. Or I already said white background here. One more try. Oh my goodness, this one's horrifying. Oh, these lesions on it. I think I'm going to go with the other one just because you could see it in full frame and it doesn't look bizarre and scary. All right, so now it's going to be downloading this. Oh, full body. Yeah, I should have done that. Now it's downloading the 1B model, which, what's the size of the 1B model? Can I see the file directory? Is it like an FTP site? No. So this is just going to take some time to download, and then it's probably going to take some time to run. So this is when Banana Man is left in the sun for too long. I missed that from earlier when someone said that. All right, so what have we done tonight? We've loaded the brand new OpenAI Point E model. We were able to run it. Some of the things that we came across was that it definitely does better rendering from images than just from the text prompt. I guess because there's that like intermediary stage where it has to figure out how to make the 3D rendering of the text. I think that what they showed in their paper here must be point clouds that were made from, these must have been made from the bigger model, which we don't have access to the full text to point cloud. But we were able to do that. It's downloading this huge model right now. We're at 1.3 gigs. In the 300M model was 1.2 gigs. So this is going to be a pretty large model. So this name is not going to be Banana Man. It'll be Yellow Puppy. We're at 2 gigs in size. Let's see if anyone on Twitter is talking about Point E. So here we have someone talking about the demos on Hugging's face. Okay, so this is just the demo site. We saw that the red motorcycle did look really good. This is just examples they're showing from their website. These are people talking about. Okay, someone did one little coder. He did an airplane 3D point cloud generated. That's pretty good. See, was this from text? Just from text prompt. So that one's pretty impressive. These are just examples that they show from their main website. We're at 3 gigs. Sorry you waste your credits. Maybe I can suggest Lion database to search for Leon database to search for images. Yeah, I can check that out. I'm thinking this 1B model is going to take too long to download, and then it's going to take too long to run. So let's just try this at 300M. I've gone back to the beginning. This dog is terrifying, though. Like, what is this in the background? A fan? A little bizarre. When did the credits also, like, when did they come back on reload on Dolly? Because I haven't used Dolly in months. All right, can we make a 3D point cloud of this using Dolly's point E model? A multicolored rainbow pumpkin. An elaborate fountain. I just don't know how these are so good. So this should take about 1.5 minutes, maybe 2 minutes for this to run because we're running the 300M model. One of the things they did say is that they were able to do this a lot faster. I wonder how slow that 1B model would take to run, though. Because the big thing is they're saying they're not necessarily beating the state of the art with this model, but they are beating it by orders of magnitude in terms of the amount of time that it takes to run. All right, it should be here. It should be done pretty soon here. Close out of this. Come on, puppy. Yellow puppy, look good. Look good. All right, it's done. Yellow puppy, finally. Let's see what this looks like. Hey, not bad. That is not bad. I will take that. Look, it's got the legs looking nice. This is not as bad as our last one. So now we're going to make the mesh from the point cloud, and it should be saved into this directory as yellow puppy .ply. And I can load it here, sorry. All right, that's done. We're going to load it up here. Oh my! There we go. Yellow puppy wearing a red collar. What do you guys think? Let's rate it. Let's get a rating going on in chat. Let's get a poll. What do you think of our Point E puppy? Love it. Love it. Horrible. No comment. Let's start this poll. We have a poll going on in chat on Twitch. Tell me what you think of our puppy. Love it? Indifferent? Think it's horrible? Is anyone going to vote on this? Go ahead into chat and let me know. Maybe no one will vote. While that's going on, I'm going to put a few links in here, okay? So if you're watching this later or you're watching this now, few things that you can use to check me out. Exclamation point YouTube, or I should just type it in here. YouTube.com/@RobMullah. That's my name. You can go there. We also have a Discord, exclamation point Discord, which you should join if you haven't already. Throw this so it's in the other chat too. And then we have, we got my Twitter, which you can follow me at. And then, of course, if you're not watching on Twitch right now, which you should be, you can check that out here. Drop me a follow or subscribe. Watch some of my videos. Let me know what you think. And thanks, guys, for hanging out with me tonight. We did test this out, and we saw it made a puppy. Now, this wasn't from a text prompt. This was from this image that we fed it in. But, yeah, that's what we got. So thanks, everyone, for hanging out. We're going to go ahead and raid a channel on Twitch. So let's find someone to raid. All 20 of you all. We have Braythorn, who's true. He's saying build your dream PC. So let's give him a raid here, and yeah, thanks everyone for hanging out. We're gonna be leaving here in a second, but I hope you guys have a good one, and I will see you maybe on Thursday, maybe on Sunday, maybe sometime in between. But make sure you've subscribed and you hit the bell and all that stuff. You'll be notified every time I go online. Also in the Discord, it'll let you know. So thanks for hanging out. See you all next time. Have a good one. All right, bye, YouTube. You guys have a good time too.